Okay? Two outcomes, success and failure. And in life, you usually want to measure your success first. We call this your P and Q. Okay. Maybe not. Here's your P. Here's your Q. Remember using those? Kinda, sorta, a little bit. Maybe. Getting better? Okay. Two possible things can happen, and only two. I can ask you a question. I could say, how many of you believe that Obama is doing the right thing, making good decisions? What's your answer going to be? Yes or no? Two possible answers. Maybe doesn't count. You can only answer two outcomes. Two possible outcomes. So, to be a binomial experiment, we need to have four things. To be a probability distribution that we did last week, we needed only two things. One, the probabilities had to be between 0 and 1. And two, the sum of all my probabilities had to be 1. That's a probability distribution. This one's different. This is binomial. Think of binomial 2. Two possible outcomes. Four things have to be present for a binomial experiment. The experiment is repeated for a fixed number of times. We call this n. I gave you this note sheet last week sometime when I thought we were going to start, and because of we had the break, I had to go back a little bit.
Oh, my name is 4.1. I ain't going to go to Miss Seagull. She can kiss my ass.
So, there are also two possible outcomes. Just two. A success and a failure. The probability itself for success or failure has to be fixed. The chance of rain is 30% at any given day. It can't be 30% today, 40% tomorrow. If I hit a home run, it's always 1/3 of the time I hit the home run. That cannot change. And the random variable x counts all your successes. I can hit 0 home runs. I can hit 1 home run. I can hit 2. I can hit 3 if I'm up 3 times the bat. Okay, so these are the notations that we're going to use through this. And if you remember, this is what it looked like. We use this. Oh, you're going to put an X here, though. We said here this is, and it works like this. This is, get rid of this guy. Oops.
Well, I did not read that before.
No, but you should have got it from thinking about it. Thinking back, how you related this. How you related this back.
I didn't relate it. Remember, I failed out.
Yes, but now that you see this, right, is it coming back? Jen, is it coming back to you?
Oh, we used R.
We used R. We put an R here. Okay? Okay, we used R for how many times it occurred. Okay? For instance, if I'm up at bat 3 times, 3 times, I'm going to get up at bat 3 times. My probability that I hit a home run is going to be 1/3. My probability that I do not hit a home run, 2/3. I want to know what is the probability that I hit exactly 2. So, here's my X value, 2. I could hit 0, I could hit 1, I could hit 2, I could hit 3. That's what this means. My random variable X is right here. My probability will stay fixed. It's always going to have to stay at 1/3. If it changes, you can't use this. I'm either going to be hitting a home run or not hitting a home run. 2 choices. I'm going to do this n number of times. 4 things have to be present. And all we're going to do is slide it into this formula. Okay? Now, in here, we have another way we're going to do this. There's a little test like in your calculator that we use for this. And it's a little, formula in your calculator. Now, and does this sound familiar now?
No.
Kind of coming back to you a little bit?
No.
Yeah, this is the part that we hated, yeah. I like this part. I thought this part had a nice pattern to it. I always liked this part. Okay, it's not going to move. All right, so let's try one. Okay. A certain surgical procedure has an 85% chance of success. Chance of success. Okay? A doctor performs this procedure on 8 patients. And every time he does, he still has an 85% chance of success. It's not going to change. The random variable represents the number of successful surgeries. In other words, out of 8, you could have no successful surgeries. 1, 2, 3, 4, 5, 6, 7, or 8. This is your random variable x. Okay. So, is this binomial? We need to determine if this is possibly a binomial experiment.
Yes.
Yes, because why?
Because it's either you die or you survive.
A success or a failure, it has 2 choices. It has 2 choices. 2 choices, success or failure. What other thing is present? How many times is he doing this experience? Okay, so he has a fixed number of trials. 4 things. We have to have 4 conditions. That's 2. What do we know about his probability of success? Is that going to change?
They're the same for each trial.
It's the same for each trial. Thank you. Same probability each trial. It's independent. And our random variable x goes from 0 to 8. So, yes. Is this a binomial experiment? Yeah. What is n?
What?
Nope. N.
It is
8.
Number of
What's p?
Use,
0.85. Let's turn our percent into a decimal. God bless you. How do I find q? 1 minus p. So that would be what? 0.15. Good. And x is going to be from 0 to 8. You can have 0 successful surgeries, 1, 2, all the way to 8. Well, not right now. We're just going to walk through this real kind of simple. We're going to discuss first, is this binomial? If it is, then we're going to make a chart. Like when you did this in Algebra 2, you usually would ask 1 question. And it would say exactly 3. So, or 4 or more. And then you did all your C plus and you strung them out. Instead of doing it that way, it's easier to make a table. I'm going to show you a little thing in your calculator to calculate it. It's kind of cool using a binomial statement. Okay, let's try another one. Or you guys try this. Okay.
Do it.
A jar contains 5 red marbles. So let's write this out. 5 red, 9 blue, 6 green. How many marbles altogether?
17.
That's not a number.
20.
That's still not a number.
20.
Well, it's better than the other one.
No. Give me a number.
I said 17.
Not a noun. Give me a number. Okay. So you randomly select 3 marbles from the jar without replacement. The random variable x represents the number of red marbles without replacement. Okay. Is this binomial?
No.
Why?
Because you're thinking it's changing.
It's changing. What is your probability of red when we start?
100%. It's not the same.
5 out of 20.
Same probability of success in each trial.
Yes, because why?
Different.
25%.
There's no replacement. There's no replacement. The next time you do this, it's going to be 4 out of 19. Okay. Everything else is there. The number of trials, we want 3. We're going to do this 3 times. We're going to do this 3 times. We want to know what's the probability of getting three reds. However, each time your red is going to change. It's either going to be a red or it's not. So you've got a success and a failure. But the problem is the probability changed. So this one is not a binomial probability distributions. Okay? You guys take a minute. And I'm having trouble with this thing. I finally got it to work. Okay, take a minute and go over this and find me the N, the P, the Q, and the X. Everybody needs to do this. All I want to know is this a binomial or not? And if it is, lay out the pieces. It's in your book on the bottom of 185. This one's always tricky. And for those taking the Algebra 2, this is a great one on the Algebra 2. Okay, you take a multiple choice quiz that consists of 10 questions. Each question has 4 possible answers, only one of which is correct. To complete the quiz, you randomly guess the answers to each question. The random variable represents the number of correct answers. Is this binomial?
Yes. No.
How many say yes?
Turn my off.
I say yes. Gunner says yes.
I
Ben says
didn't.
yes.
The thing is I didn't, but then I thought because with the marbles, there was multiple, you could have gotten a green marble or blue marble, and this one, there's 4 answers.
Yes, but all we do is get, in the marbles, all we do is get a red or not a red.
But
So,
that one wasn't.
but it wasn't because, that one wasn't because your probability changed.
Oh,
because we didn't replace.
Gotcha.
But the rest of everything was there. So this one, Joe, how many possible answers can you get on your multiple choice? This is what your multiple choice looks like. All the way here to 10. Each question has the same amount. A, B, C, D has 4 choices. How many answers are correct? 1. So your probability of getting this correct is what? 1 out of, okay, or 1 out of 4. Your probability of not getting it correct, getting it wrong, okay, is so 25% versus 75%. So is that going to change with each question? What changes is which one is right. Like I can have A the first time, B the second time, but I'm still, I could put C this last time, but it's still 1 out of 4, 1 out of 4, 1 out of 4. How many questions am I doing this for? 10. That's my N, my probability of success, my probability of failure, and X represents the number of correct. If I guess, how many can I possibly get correct? 10.
1,
1,
2, 3.
2, 3. How about 0? Can I get 0? I can get 0 correct. All the way to 10. I'm sorry? X is like listing all the possible things that can happen. I can get 0 correct, 1 correct, 2 correct, 3 correct. Okay? So this meets our 4 criteria for your binomial distribution, your binomial probability distribution. My probability does not change. This is a great one on the Algebra 2 because kids get so confused right here. There are 4 possible answers and there are 10 questions. You know how many times kids write the probability 1 out of 10? But there's each, but what helps is this. Look, draw this out like this as if you were really taking this test. What would happen if I had 3 possible answers? What would change? So what of those things are going to change? The P? My P would go to what? 1 out of 3. And what would my Q go to? 2 out of 3. I'm going to still do this 10 times. I'm going to still get only 1 correct answer out of each trial, right? And my X is not going to change. My variable is not going to change. It's going to still be from 0 to 10. Okay. Questions? Now your favorite part. Guys. Okay. Here is your binomial probability formula. Now, let's just take a look at the one previously. We said n is 10. The probability of success is 1/4. The probability of failure is 3/4. And my X went from 0 to 10, right? Okay. If I want to know what is the probability of getting exactly 3 questions correct out of the 10. We proved that this was binomial, right? I'm going to use the same thing. Watch where this pattern goes. If I want 3 out of 10, first thing you say is, does it matter what order they occur? No. So therefore we start with a C. How many times am I doing this? How many questions was there? 10. How many did I want right? 3. You always measure your success first. So what is the probability of getting an answer right? Think back to the one we did. How many choices were there? 4. So 1 out of 4. How many did we want? 3. Now measure our failures. 3/4. And how many do we want? 7. How'd you get 7?
Because that's the opposite of 4 correct. I mean 3 correct.
Okay, that's what's left over from 3 correct. 7 incorrect. Isn't that this? 10 minus 3? There's my 3. There's my 10 minus 3. Isn't that this? 10 minus 3? See it? Yeah, that's this, 10 minus 3. That's this piece right here. Would I do it this way? No, I wouldn't work it out the way they did. I would just put it in my calculator. But that's all this is. It's just a pattern. It's a pattern. We also have a probability statement in your calculator. Now, if you grab your calculator, come on guys. You know how to put this in your calculator first? You have to put your 10 in, then your C. You'll find this in math. Go to probability. Go down till you see the C. Then put this in. Then put it exactly the way you read it. If you want to use 0.25 and 0.75, that works just as easily. Sure. Put the 10 in. Now go to math. It's on the left-hand side. Scroll to probability and come down to the NCR, number 3. So you should see 10, NCR. Now you put in 3.
You got a big decimal.
Okay. See if you can flip it to a fraction. Hit math fraction. And then put this in. And I said if you wanted to, you could put...
You got a big decimal.
Okay, so it's just going to stay as decimal. You could put your decimals in instead of your fractions. Yes. The 3 we wanted to have 3 correct. It was my problem. It was there. Okay, so we decided we can't flip this back. So you got something like this.
250.
So let's round to 3 decimals.
250.
Okay, now. Okay, everybody listen to me. I want you to hit, you see the word VARS on your calculator? VARS is by the clear button. I want you to hit second VARS. Now, I want you to go down till you see something that looks like binomial PDF. Tell me what letter you see. I want to look for a binomial probability distribution function.
There's a name.
That means binomial PDF. Do you see that? Do you see what it stands for? Right at A.
Wait,
Now,
A or 0?
it depends on your calculator.
Oh, okay.
Yeah, it depends on your calculator. Now, hit that one. If you have the updated software, I'm working on updating all of them. It'll say this. It'll say trials, P, X value.
So what do we
Okay, so if you don't, it's going to go in that same order. Trials, P, X. Now, this is how I remember this one. N is what my trials are. They're in alphabetical order. N, P, X. Now, if you don't have this, you've got to just put a parentheses. And how many times are we doing this? 10 times. What was my probability of being correct?
25%.
25%, 0.25, or 1 out of 4. And how many did I want? I wanted 3. We wanted exactly 3. God bless you. Now, if you don't have that one, do it like this. 10.25, comma 3. Do you get the same thing?
Yes.
Yes. Which one do you have? Do you have this, Cypress, or do you have to put... So trials is your N. How many times did we do this? 10. Probability of being success, you could either put in 1/4 or 0.25. My X, I want exactly 3. And hit enter. We'll go down to paste. Go down to paste. And what it does is it pastes this in, just like this. It pastes it in. And remember, it's alphabetical order. N, P, X. Now, do you find that easier than doing the C formula? Yeah. Now, what we're going to do tomorrow is continue this with all the possible things and make a table out of this.
I feel like if you study the calculator instead of doing the
How are we with this, guys?